everyone. Yeah. So recently I was traveling to a grad school in Georgia, UGA, and I was thinking, what if there's a way to actually take campus tours and not have to travel across states, or for high schools to implement some sort of virtual tour so that prospective college students could more easily take college campus tours. So that's where UniVirt came into play.
My name is Michael McLerran. I was in charge of modeling and texturing Laffrey and Picard halls, and I was also involved with the advanced modeling of the benches and the circle drive located in the north side of the quad.
My name is Ben Riemann. I spoke a little bit ago, but I was in charge of modeling and texturing Switzler Hall, if you know where that's located, as well as the Chancellor's House. A little bit of character implementation was kind of my big deal. That was one of the big hassles that we knew were coming in this project, so I figured I'd take that on, see what it was like. And then also I assisted with the user interface as well, and advanced modeling included sidewalks, circle drive, and lighting, and some of the foliage. So
Yeah, I was team lead. My name's Kyle Morrison. I took care of RJI and Jesse Hall. I built the trash cans. I built the fencing and the poles for the fencing. Built most of the foliage around campus, the sidewalks, and I also helped with character implementation and user interface, and I also recorded the sound that you will hear in the tour with Tim.
My name is Tyler Weis. I did the modeling and texturing for Swallow Hall, and I also did the advanced modeling for all the light posts found across the quad.
And I'm Tim Watson. I did modeling and texturing of Neff Hall, Walter Williams Hall, the Geological Sciences Building, and Gannett Hall. I created sound cues for some of the bites we did. I did sound recordings for the history of some of the buildings along with Kyle, and I modeled the columns along with working on the UI. All right, now to make this project happen, we needed 3 software packages that we could use. The first was we needed to get the dimensions of the building so we could actually build them. So what we did was we employed Google Earth Pro, which is like Google Maps, but it has, besides the satellite imaging of, let's say, the Francis Quadrangle, we can do it in 3D space so that we can measure the height, width, and length, basically the dimensions of the buildings. Now, these buildings were hundreds to thousands of centimeters in length. Now I know what you're thinking, why did you measure in centimeters? Well, that's because the Autodesk Maya suite uses centimeters in their grid layout, so 1 centimeter is 1 grid unit in Maya. Now, what's Autodesk Maya? Well, it's a 3D modeling application software that basically you can use primitive polygonal shapes like cubes, spheres, cylinders, or cones to create more complex objects like, let's say, buildings or benches or characters. So what we wanted to do was get the dimensions of the buildings from Google Earth Pro, lay them out in Autodesk Maya, and build them using 3D modeling. After that, we decided to either use texturing in Maya or Unreal Engine 4. We decided to go with Unreal Engine 4 for texturing, using Maya for the base layer. So I know you're thinking, what's Unreal Engine 4? Well, it's a game development kit that you can use to create games or do modeling and texturing. So we wanted to focus on texturing. So what we did was we used Unreal Engine 4 as our sandbox and brought all of our assets and our buildings from Maya over into Unreal Engine 4, like our buildings or our benches or our foliage. Now, in Unreal Engine 4, we did the texturing. Now, you might be thinking, what's texturing? Well, it's basically we took our 3D objects and almost applied like a 2D poster to each side of the object. And the texturing or skins, we wanted to replicate real-world objects like stone or brick or anything other like that. So once we brought our buildings over to Unreal Engine 4 and textured them, that's when we really started having fun.
So some of the challenges that we knew coming into this project, one of them was going to be the Oculus frame rate. As you know, with building 3D objects and building a 3D game, you're going to have heavy and graphically intensive objects in your game. So that was kind of one of the things that we thought about, and we were kind of thinking about how we can like make that better. Obviously, we want more frame rates. We were shooting for 75, and we did hit that, by the way. And another thing we did was clipping. Some of you may know what this is, but like with the Oculus, you have a headset on. Also, you have a motion tracker for the headset, so it tracks every motion that you do when you look. You can also bend forward, and it tracks that motion. So it's almost like when you're in your real life. You bend forward, you actually look down at the ground. So if you're next to a building, we had some problems with that people online were saying, if you're next to a building and you look forward, you can see through the building. It's something obviously you don't want to have happen in a game, but that's something that we knew going into it and that we were thinking about beforehand. Also the character implementation, like I said, I was taking on the character implementation. There's a lot of things interacting with the character, just basically being able to, the physics and walking around and everything, but also where the camera is on the character. Obviously when you're in a real life 3D game, you want to make it feel real life. So you want the camera to be located on a central part of the body of the actual character. And so basically just figuring out what was going to be real, everything coming into play was just kind of another little challenge that we knew coming into it.
So during our design process, we decided to use Maya to create our buildings and then Unreal to create our game world. We decided to use Maya for our buildings because you can make more intricate buildings using it, and we've also all had previous experience. And then one of our challenges with it was that Maya was difficult to import into Unreal, but we figured all that out. And then whenever you used Unreal for simpler buildings, it eliminates that for the importing. And then we created a nice game world in Unreal.
Another issue that we had to deal with was, actually, skip this slide. Sorry, we took this out because we're just not much time left. So another issue that we had to deal with was light mapping issues. These came about once we exported our objects from Maya into the Unreal Engine. What these issues pretty much entailed was the creation of shadows, or incorrect shadows, all over the quad, which were not supposed to be there.
So the reason that this was happening was because when you would export your object from Maya and then import it into Unreal, Unreal would go ahead and create a light map for that object, and it would usually do it incorrectly. So you'd have to go into Maya, tell it how to actually have the light map, and then re-import it and tell Unreal not to actually create a new light map for it. And then that actually fixed our lighting errors. So here's a short little video, just basically of our building process. So we'd get together about 2 or 3 times a week, sit down for 4 to 7 hours, and crank out these buildings for about 2 months straight. It was a long process, but being in this close environment allowed us to actually work together a lot easier. And you can see I'm using Maya right here. I have Google Earth Pro open in my other monitor. And so I was able to go over, measure, come back over, make sure it's the right size, see what it looks like. And then like I was saying, it helped that everyone was there, so I could talk to everyone, see what the problems were, and we could just help each other out. And so this was at my apartment. We also would work in the VR lab. We used the VR lab mostly just to make sure that our Oculus implementation was working correctly, getting the UI down, making sure that it works with the Oculus. And then once we actually got through all this, we got to go through our beta stage, and we got to have people come and try out our demo for our game. So what's happening right here. They got to jump around and make sure that there was no clipping and all that good stuff. So yeah, and so now it's time for the demo.
Does anybody have any quick questions while we're switching that over? It's a good time for it.
I was just going to ask, do you feel after all of your experience so far that you can work out the kinks and that there's a business model for producing this game, and can you make money doing this?
Awesome question. After getting hands-on work with this, obviously we worked our way through all these. We had a lot of errors, I'm not going to lie, and we spent a lot of mornings working on this stuff to get it done, especially when they moved our timeline up 3 weeks. So we worked through a lot of errors, but once we got those errors down, it was like, everything was flowing smoothly. And like Kyle was saying earlier, we're really trying to reach out to people who can't make this travel. So we're thinking maybe like high schools in a counselor's office, maybe they can have an Oculus set up, and students, if they can't make it to the place they want to visit for the campus-wise, have them go into the counselor's office, have them, I mean, the game is easy. It's just a download, quick download. They can visit any kind of campus they want to as long as we can build the campus. Like I said, we worked through those problems, so it's not that big of a deal to do. And high school students can have their hands on this, and they can experience any campus they would like to if we can get it built on for them. So I think there's a great potential for this thing, and we were so excited to be able to do this, and we're just happy to be here.
Having done it once, does that make it easier to do the next time?
Definitely. Like I said, most of our problems came with like importing, exporting, with all the different shadings and everything. So when we finally got that all figured out, it was a pattern. We just had to do the same thing for everything that we imported and exported, and it just made it a lot smoother, a lot easier, because we knew what we were doing. And there wasn't a lot of help out there. The Oculus is pretty new. There's a lot of people out there doing the same thing, and there's a lot of people understanding there's errors and trying to work through them with you. But since it was so new, we kind of got our hands on and got down and dirty with it and finally got it figured out. So and it can help everyone else out there doing the same thing.
Welcome to the University of Missouri Francis Quadrangle. Francis Quadrangle, with the columns in the middle, is the symbolic center of Mizzou. It's modeled after Thomas Jefferson's design for the University of Virginia. A small statue near the steps of Jesse Hall honors Missouri Governor David Francis, who after the 1892 fire helped secure funds to construct 5 buildings and ensure the university's continued existence in Columbia. Francis Quadrangle, the columns, and the 18 surrounding buildings were named to the National Register of Historic Places in 1974. The columns are all that remains of the Academic Hall, the first and main building on campus until it burned down on January 9, 1892. The columns were originally deemed to be unsafe, but a rally in their defense kept them on campus.
Yeah, there's all these audio clips in there. You get near, there's instructions on the first page. You get near them, you can press a button.
Events that take place
Tells you a little bit about the history. There's also, like he was saying, a sound capsule. If you get outside the sound capsule, it just kind of fades away like you're walking away from it. And then you can go visit other little monuments on campus. A lot of modeling going on here. There's a lot of.
Lafferty Hall, home of the Department of Engineering.
We spent a lot of time on modeling.
Began a proud engineering tradition in the state.
Great learning experience, though, for sure.
Engineering training west of the Mississippi River. In 1849, the first civil engineering course was offered at the University of Missouri. The civil engineering program, which soon followed in 1856, is only 3 years younger than the oldest in the country, Thomas Alva Edison.
So this is just basically the 2D version of it. When you're, yeah, there you go. 2D version of it, and then you put the Oculus on, then you're in the 3D world. It's really simple to switch over. But when you see when you're actually watching this, someone do the Oculus, it shows 2 displays like it would be 3D mapping. So it looks really goofy when you're looking at it like right here. But so we're just going to play this 2D with you, and if we have time, we'll throw on an Oculus and let you look at it. Also, the virtual reality room over there in EBW. There's always get in touch with one of us, and we can have you come in and do a tour of it as well, if you like what you see.
This is really cool, and I hope that you guys can stick around until our break. If you can, I'm sure there'd be a couple of folks who'd like to come up and put on the headset and see what it looks like that way. But this is great. Thank you so much for the demo. We appreciate it.
Yes, we'll stick around, and we'll leave this plugged in. Thank you.